we have a question, prove that root 5 is irrational. So in order to prove that root 5 is irrational, we considered root 5 be a rational. Now if root 5 is rational, we can write root 5 in form of p by q, where p and q are co-primes. That is, they don't have a common factor other than 1. Now squaring both sides, root 5 square is equal to p by q square. We will get 5 p square upon q square. 5q square is equal to p square. Now we have learned a theorem that if p divides a square, then p divides a also. So 5 here divides p square, then 5 divides p also. Now consider that 5 divides p c times, that is p is equal to 5c. Consider that as equation 1 and put the value of p in equation 1. 5q is equals to 5c whole square. 5q is square is equal to 25c square. Q is square is equal to 25c square upon 5. Q square is equal to 5c square. Now if 5 divides q square, then 5 divides q also. Now we have seen that 5 divides p also and 5 divides q also. Therefore, consider this as equation 2 and consider this as equation 3. So, by second and third, we get what we get. 5 is a common factor of both p and q. But this contradicts to our assumption that p and q are co-primes. Therefore, root 5 is a irrational. So we have a next question. Prove that 3 plus 2 root 5 is irrational. In order to prove this, let us consider 3 plus 2 root 5 is a rational. So if this is a rational number, then we can write 3 plus 2 root 5 is equal to p by q, where p and q are co-primes. Now we will square both sides. You can write here squaring both sides. We will use the formula a plus b whole square. Now, solving the further equation, We will move 29 towards right hand side. We'll take the LCM as q square and multiply q square with 29. Now this is 12, where multiply we will put down by dividing it. But we know that root 5 is not equal to p square minus 29q square upon 12q square. Give the reason: because root 5 is irrational while p square minus 29q square upon 12q square is a rational. This contradicts to our assumption that three plus 2 root 5 is a rational. Therefore, 3 plus 2 root 5 is irrational. Moving on to next question, we have 1 upon 2 and we have to prove that it is irrational. Solving. Firstly, we will convert 1 upon root 2 in standard form by multiplying it with root 2. We will get root 2 upon 2. Now, in order to prove 1 upon root 2 as irrational, let us consider 1 upon root 2 as rational. So, we can write 1 upon root 2 in the form of p by q, where p and q are co-primes. We have the value of 1 upon root 2 as root 2 upon 2. You can consider this as equation 1 and give the reference by equation 1. Now, since it is in 2 is in divide, we will put 2 as multiply. But root 2 cannot be equal to 2p upon q, because root 2 is irrational while the term 2p upon q is rational. This contradicts to our assumption that one upon root 2 is rational. Therefore, 1 upon root 2 is irrational. Next question, we have 7 root 5 and we have to prove it as irrational. Further solving, let's consider 7 root 5 be a rational. If 7 root 5 is rational, then we can write it as p by q, where p and q are co-primes. Now, We have 7 here in multiplication. We will send it as divide. So there will be left with root 5, 5, 7q. Now, but we know that root 5 cannot be equal to p upon 7q because root 5 is irrational while p by 7q is a rational. This contradicts to our assumption that 7 root 5 is a rational. Therefore, 7 root 5 is irrational. So we have next question to prove 6 plus root 2 as irrational. In order to prove this as irrational, we will let 6 plus root 2 be a rational. Now, if it is a rational, we can write it in the form of p by q, where p and q are coprimes. Now, on squaring both sides, you can give the reference squaring both sides. P square upon q square. Now 38 plus 12 root 2 is equal to p square upon q square. Further solving, we will send 38 to right hand side. Taking the LCM as q square, we will get 38 q square upon q square. Now here 12 is in multiplication, we will send it to right hand side as divide. But root 2 cannot be equal to p square minus 38 q square upon 12 q square because p square minus 38 q square upon 12 q square is a rational while root 2 is irrational. This contradicts to our assumption that 6 plus root 2 is a rational. Therefore, 6 plus root 2 is irrational.